Hello everybody and welcome back. Welcome back. We're looking at the grade 8 Gauss paper from 2006 and we are on question 6. How many prime numbers are there between 20 and 30? Okay, now sometimes when people ask how many numbers are there between blah and blah, they're a little vague as to whether or not the endpoints count, but don't worry, 20 and 30, they're not prime numbers, so it doesn't matter. So we're just looking at 21, 22, 23, 24, 25, 26, 27, 28, and 29. Which of those are prime numbers? Okay. Now, if you don't remember, that's okay. I'll throw out a little definition, and if you want to, if you didn't know what a prime number is, after taking a look at this definition, pause the video, see if you can figure out this question on your own. So a prime number is an integer or a whole number, p, so that the only numbers that divide, I should probably also say an integer p greater than 1. You don't have negative primes, 1's not a prime, 0's not a prime. So the only numbers that divide p are both 1 and p. So, for example, 3 is prime, because 1 divides it, 3 divides it, but no other number divides into 3. Okay? 6 isn't, because it has 1 and 6, but 2 also divides 6, that sort of thing. Okay? So, if you didn't know what a prime number is, pause the video, try it now, otherwise I'm going to proceed onward. So we're looking at for primes between 20 and 30. Well, let's take a look at the numbers between 20 and 30. Now, some of you out there, if you've been doing math for a while, you tried some of these contests, you're probably going to know some of your prime numbers already. And so you might say, well, 23, that's a prime, and I know that's a prime. But if you need to, calculators are allowed. Grab your calculator and just try dividing things. 21, does that divide by 2? No. Does it divide by 3? Well, yeah. So it has a factor. It has a number that divides it other than 1 and 21, namely 3 divides it. So 21 is not prime. 22, that's divisible by 2. In fact, all these even numbers have a factor 2. 2 divides them, so they can't be prime. Okay? 5 divides 25, 3 divides 27, but try as we might, we won't find anything that divides 23 and 29. Now, a little trick, in case you're interested, if I want to know, so if I want to check if n is prime, the fastest way to do that with a calculator, I just ask, does k divide n for any prime k, and that k has got to be between 1 and the square root of n. Okay? So if I want to check whether or not 23 is a prime, I just need to ask myself, does it divide, well first of all, what's the square root of 23? It's a little less than 5. So, for k being equal to 1, 2, 3, or 4, I ask myself, does k divide 23? Now, you can get away with just using prime k's, but if you if you can't recognize which of these are prime, just try any number k. Okay? But if I'm just using primes, I don't need to check 1. I don't need to check 4. So just ask, is 23 divisible by 2? No. Is 23 divisible by 3? No. Well, then it's got to be prime. Okay? Same thing with 29, although you'll go up to 5. And you'll ask, is 29 divisible by 2? No. 3? No. 5? No. It's got to be prime. Okay? So this is the fastest way to check whether or not something is prime. But to answer the original question, there are 2 primes between 20 and 30. And that's an answer of, right in the middle, it's C. Okay. So hopefully that helps you out. If you didn't know prime numbers, maybe you know them a little better now. And in the next video, we're going to take a look at question number 7. So thank you for joining me. I'll see you guys there.